Welcome back. In today's session, we are going to see how the production scheduling is carried out in industry. By taking one simple example, numerical example, we will understand how the scheduling process is done in the industry. So let us see the basic scheduling problems. The various production scheduling techniques depend on the type of production, type and frequency of jobs, demand patterns, and flexibility offered by available processing time. So some of the basic scheduling problems are given like this. So one, it is called the job sub scheduling, also known as the unit scheduling. Second one is batch production scheduling. Third, flow production scheduling. And the fourth one is called production sequencing, product sequencing, right? So let us deeply explain the job sub scheduling procedure, which uses one Johnson's rule. Okay, so we'll see a simple problem. And before that, what are the rules? Why it is called the sequencing? The scheduling rules, when many jobs are waiting before an operational facility, for example, some queues are formed before one machine or work center, then we have to decide which one should be carried out on the machine first and then second. So this sequencing is called the scheduling rules. So there are many rules. So we should have some rule to decide the priority of sequencing. Sequencing rules or scheduling rules, also known as priority rules or dispatching rules, used to obtain the job sequence which will be done first, second, third, like that. Priority sequencing is a systematic procedure for assigning priorities to the waiting jobs, thereby determining the sequence in which the jobs are to be performed. So let us take one simple example, a numerical example for understanding this job sub scheduling. So the rule here, it is the Johnson's rule. I am explaining how this Johnson's rule is followed for obtaining the best optimal sequence of jobs. So let us assume that there are 5 jobs, namely it is A, B, C, D, E. So there are 5 jobs are waiting to be completed, and we are having 2 machines, M1 and M2. Okay, so assuming that we are given the processing time of each jobs, that is all 5 jobs in these 2 machines are given in this table. The processing time of 5 jobs on the 2 machines are given, and we are using Johnson's rule to schedule these jobs, and we have to find the minimum total flow time. So the condition is both the machines should be used in the order M1 first machine and this second machine. All the jobs are to be processed in both the machines by this order only. So we cannot skip the machines. So that is the rule followed in the Johnson's rule of scheduling. So the Johnson's rule said that, so given this working hours, so we have to find which is the lowest or the least flow time, that is the schedule time, right? So in this table, so we can find this. So number 2 hours the job C is having in machine 2. So this should be taken, and we have to design one order, that is in A to E, that is 5 boxes will be drawn first. Then as this job C is having the least hour of manufacturing or processing time in machine 2. So if the minimum time comes for the machine 2, it will be written on the right hand side, right end of the line. and if it is the least number comes in the first, we have to write in the left first box of the sequence. So let us see that. So here the job sequencing is like this. So we can, as we have seen, the C is having minimum, the least processing time, that is 2 hours. So in the sequencing, as the 2 hours is in machine 2, so it will be written on the last box of the sequencing box. Then we can find that the next least time is for 3. So C is over. So that is, we have decided that the C job is to be done on machine 2 in the last. Right. Then comes the number 3. So 3 hours is the next least hour. This is for A, and this is also for the machine 2. So this 3 hours for A is on machine 2. So it will be written next box of the right end, right, like this. So it is written that, so it is in second machine and it is having the next least time. So after C, you have to write A. And so we have, this is that this sequence of C is the last and A is the next last, right. So by seeing the next level of higher order, that is after 2, 3, and we are seeing that the 4 hour is the next least hour, processing hour. So here B is having 4 in first machine, and also D is also having 4 in the second machine. So this D having 4 hours should be in the second machine. So after C and A, and before C and A, this should be completed. So 4 will be taken, and as the B is having 4 hours in the first machine, it will become the first job. So it will be given the priority in the 1. So you can see that, so job B will be in the first order, and the D will be before C and A, so D will be taken. And the remaining box will be filled with the remaining job. So as we have already A, B, C, D, remaining is E, so that will be written in that box. So this sequencing, so this is B, E, D, A, C. So this is the sequencing by using the Johnson's rule. So this sequencing will be followed for getting the minimum workflow. So let us see the Gantt chart having these orders. So B, E, D, A, C on the machine 1 and machine 2. So for machine 1, first we have to take the B job first. In B, in first machine, it has 4 hours. So in the Gantt chart, the hours, B will be noted 4 hours. Then after this machine 1, it goes 9 hours in machine 2. So after completing in machine 1, the product goes to machine 2, where it will take 9 hours of processing, and the B will be over. So first it will take at machine 1 4 hours. Then after that it will goes to the machine 2, and it will having 9 hours of processing time. So the B will be completed. Next we have to take E in first machine. So E is having 6 hours. So after completing B, so we have to load the machine with E job, and it will be processing for a minimum hour of 6 hours. Then 6 hours in machine A. After completing the 6 hours, then it will go to the machine 2, 10 hours. So the E, after completing in machine 1, then after completing the job of B in machine 2, it will be loaded E for 10 hours. Like that, the next job will be taken as D, which will be having 7 hours in machine 1 and 4 hours in machine 2. Then comes the A. So A will be process 5 hours in machine 1 and 3 hours in machine 2. Then last C. So C will be 8 hours in machine 1 and 2 hours in machine 2. So this is the sequencing for loading the machine 1 and 2, and we can see that the machine 1, while it is processing B, the machine 2 will be in idle condition because there is no load, the machine is not loaded with anything, so it will be in idle position. So we can see that the first 4 hours of the machine operating time, machine 1 operation, so the machine 2 will be in idle. So 4 hours will be idle for machine 2. And similarly, if you see that after completing all the jobs in sequence, the machine 1, it will be in idle condition. So it will be in idle condition while the machine 2 is in processing. So we can see that the last 2 hours where the C is processing and machine 2, so the machine 1 will be in idle condition. So we can take a cumulative of these orders. So we can calculate the total hours of completion is now, it is nearly it is 32 hours by seeing the Gantt chart. So we can either we can calculate it or we can draw the Gantt chart, and we can see that the total time for completing all the 5 jobs will be taken 32 hours, and the idle time for machine 1 will be 2 hours, which is in the last processing, and for machine 2 it is 4 hours, for it has to wait for the job to come, and which is B, that is the machine 1, 4 hours. So that will be the idle time for the machine 2. So this way we can sequencing the job. So this is called the production scheduling, and this is called the production sequencing also. And the orders are sequenced in such a manner that the flow time or the total work time will be minimum. And so this is the method we are using the Johnson's rule here for getting the optimum sequencing time, and by calculating the idle times for each machine. So this is the method followed for the n number of jobs on 2 machines. So like this, it can be carried out to the job sequencing on 3 machines also. So we will see in next session how the sequencing is done for 3 machines. Thank you.